Dear students, let us see the concept of correlation in today's lecture. In previous lectures, we have seen measures of central tendency and measures of dispersion, in which we have considered only one variable at a time. But in practice, we hardly meet such simple situations. Many times we come across problems involving two or more variables for a single atom. Many business problems involve two or more variables, for example, price and demand of a commodity, income and expenditure of a family, heights and weights of a group of persons, ages of husbands and ages of wives, etc. In above examples, we can observe that if one variable changes, other also changes in the same or opposite direction. That is, there is some relation between two variables and are said to be correlated. Let us see the definition of correlation. The study of existence, magnitude and direction of the relation between two or more variables is called correlation. In other words, correlation is a statistical tool which studies the relationship between two or more variables, and correlation analysis involves various methods and techniques used for studying and measuring the extent of the relationship between two or more variables. For example, we may study the correlation between demand and supply of a commodity, price and demand of a commodity, sales and profits, expenditure on advertisement and sales, accidents and motor vehicles, rainfall and agricultural production, petrol consumption and miles traveled, income and expenditure of a family. So let us see the uses of studying correlation. The correlation analysis is widely used in economics, business, and many other fields because it helps to predict, to control, and to plan our activities for the future. Now let us see the types of correlation. Following are the main types of correlation: positive and negative correlation, linear and nonlinear correlation, simple, multiple, and partial correlation. Now let us see these types in detail. Positive and negative correlation. The difference between the positive and negative correlation depends upon the direction of change of two variables. If both the variables change in the same direction, that is, if one variable increases, other also increases, or if one decreases, other also decreases, then the correlation is said to be positive or direct correlation. For example, age of applicant for the life insurance and the premium of insurance, advertisement and sales, the family income and expenditure on luxury items. So these are positively correlated. On the other hand, if the variables change in opposite direction, that is, if one variable increases, the other decreases, or if the first decreases, the another increases, then the correlation is called negative or inverse correlation. For example, the price and demand of a commodity, development in medical science and death rate, TV registrations and cinema attendance. So these are negatively correlated. Next type is linear and non-linear correlation. So this type is based upon the nature of graph of the relation between the two variables. If the graph is straight line, the correlation is called linear correlation. This is the concept of linear correlation. The line showing a straight line. If the graph is not a straight line but a curve, it is called as non-linear or curvilinear correlation. Such phenomena are common in the data relating to economics and social science. For example, rainfall and production of paddy. So this is the nature of curvilinear linear correlation. Now let us see the difference between simple, multiple and partial correlation. In simple correlation, we study only two variables, say price and demand of a commodity. In multiple correlation, we study the relationship between three or more variables. For example, production of paddy, rainfall, and use of fertilizers, etc. In partial correlation, though more than two variables are involved, but correlation is studied only between two variables and the effect of other variables are assumed to be constant. For example, the correlation between yield of paddy and fertilizers excluding the effect of rainfall is a partial correlation. Now let us see the methods of studying correlation. Following are the commonly used methods for studying the correlation between two variables: graphical methods, scatter diagram method, and simple graph. Mathematical methods: Carl Pearson's coefficient of correlation, small r; Spearman's rank correlation coefficient, capital R; concurrent deviation method; and last one, method of least squares. So we shall discuss only scatter diagram, Carl Pearson's coefficient of correlation, small r, and Spearman's rank correlation coefficient, capital R, for our study. Now let us see the concept of scatter diagram method. So scatter diagram is defined as, scatter diagram is a graph showing the correlation between two variables. So here n pairs of observations x1, y1, x2, y2, dash dash x and yn of two variables x and y are plotted as dots on xy plane, taking independent variable along x-axis and dependent variable along y-axis. So by plotting the data on graph paper, we get the points or dots which are generally scattered, and so it is called as scatter diagram or dot diagram. The manner in which the points are scattered suggests the degree and direction of correlation. The degree, that is magnitude of correlation, is denoted by r, small r, and the direction by its sign, positive or negative. Now let us see how to interpret the scatter diagram. If all the points lie on a rising straight line towards the right, the correlation is perfect positive, and in this case value of r is equal to +1. For example, the correlation between amount of deposit and amount of interest, amount of loan and amount of loan interest. Second, if all the points lie on a following straight line towards the right, the correlation is perfect negative correlation, and in this case value of r is -1. For example, amount of loan paid and amount to be paid, pressure and volume of a perfect gas. If all the points lie in a narrow strip which rises towards the right, the correlation is said to be high degree positive correlation or strong positive correlation, and in this case the value of r lies between 0.8 and 1. For example, sale and profit, cost of advertisement and sale. Next one is, if all the points lie in a narrow strip which falls towards the right, the correlation is high degree that is strong negative correlation, and it lies between value of R lies between -1 and -0.8. For example, price and demand, rate of interest and number of loan agreements. Next one is if all the points lie on a broad strip rising towards the right, the correlation is low degree correlation or weak correlation, and in this case R lies between 0 and zero point 0.4. For example, rush in hotels and number of marriages, day temperature and sale of cold drinks. Now, if all the points lie on a broad strip which falls towards the right, then the correlation is low, that is weak degree negative correlation, and in this case minus zero point 0.4 less than or less than 0. For example, day temperature and sale of hot drinks. And the last important point to be considered here is if the plotted points are scattered without any pattern, then there is no correlation or zero correlation between two variables, and in this case value of R is equal to 0. For example, weight of a student and marks obtained, or ST bus fare and rainfall. So these variables are not correlated at all. So all above points are shown graphically here. So this is related to a narrow strip. All the points lie on a narrow strip which rises towards the right. So here in this case there is high positive correlation. So here this strip is falling towards the right and the strip is narrow. So therefore here is high negative correlation. So in this case all the points lie on a broad strip which rises towards the right, the correlation is low positive correlation, and as this broad strip falls towards the right, the correlation is low negative correlation. So here there is no any pattern, and this indicates there is no correlation, that is zero correlation between x and y. So this is one of the slide from uh, other presentation. So this depicts all the points lie on a straight line which rises towards the right. So there is perfect positive correlation. In this case, value of R is +1. So this is the concept of all the points lie on a straight line which falls towards the right, and in this case there is perfect negative correlation and value of R is -1. Okay, and this is regarding to positive correlation, this is regarding to negative correlation, this is regarding to zero correlation. Now let us see one problem based on scatter diagram. Following are the heights and weights of 10 students of a become second class. Draw a scatter diagram and indicate whether the correlation is positive or negative. So they have given heights and weights of 10 students here. So we can plot them on XY plane, and the plotted points like this. The scatter diagram of above data is as follows. So if we observe that all the points lie on a strip which rises towards the right, and this indicates that there is positive correlation between height and weight of the students. So in next lecture we shall discuss Carl Pearson's coefficient of correlation small r. Thank you very much.